Okay. So, electronics, just like I said kanina, parang almost kung saan man tayo tumingin, meron na tayong electronic parts. Usually, yung makikita ninyo sa inyong cellphones. Sa bahay, lahat ng mga appliances, TV, and other sa school, almost lahat meron na tayong electronic parts. So, electronics are used everywhere from home, sa work, sa government, even when we travel, and even nga din sa outer space, meron tayong electronic parts. So quite often, we only realize their value in our lives when an electronic gadgets gets damaged, or when we experience a power failure for some time, and when everything seems to set in that without electricity, yung halimbawa, nawalan nga ng electricity, yung iba nagpapanik na wala kaming wifi, ganyan. So, pero ang electronics, kung dadalhin natin yung kanyang advantages, we have improved in our communication. Sa tingin nyo, paano naging improvement sa communication yung electronics? Iko-compare nyo dati. Ano yung naging improvement? Anyone? Yes. Tayo muna. Yung sinong nauna? Sebastian.
Ma'am, for me po, mas mabilis po yung dating ng mga, ng mga gusto po nating i-communicate, especially messages po, compared po noon.
Okay. Kumbaga dati, sige, isa pa. Sino yung nag-raise ng hand? Wala. Yes, Hans.
Ano po ma'am, mas madali po sa atin na mas ma-gets kung ano yung pinararating ng isang tao. Tapos yung pong mga gawaing mahirap is napapadali. Ganun po.
Okay. Other. Sino pa? Example na paano naging improvement? Ano yung naging improvement? Example. Yes, Hans.
Yung pong tulad dati na yung pong kailangan ng messenger na actual iabot sa bahay. Ngayon po is dahil po sa technology is through communication or email masesend na. Ganun po.
Tama. Tama yung sinabi niya. Okay. Hindi niyo na siguro naabutan yung kapag merong yung sulat, naabutan niyo pa na pa kayo ng snail mail. Hindi, no? Or even yung kahit sa magkakaklase, magkukulitan or magsasabihan ng mga messages through maliliit na papel, mag-aabutan. Ngayon, ite-text na lang, or yung paghalimbawa, saan pa may improvement in home entertainment? Paano kaya nag-improve? Yes, Melvin.
Nag-improve po ang home entertainment po, bale po sa pagsisimula po ng pagkakaroon ng radyo. Then nagkaroon po, tapos nagkaroon po ng TV, which is black and white pa dati, na naging colored. Tapos po unti-unti ay nag-improve yung pagiging CRT TV na naging LED TV po siya.
Tapos ngayon may mga 4K at kung ano-ano ng mga technology, na mas kitang-kita mo ng parang pag may tawag dito. Tsaka malaki na yung size. Hindi lang sa quality, pati sa size. Nag-improve din siya. How about sa health industry? How does it change yung ating everyday life sa health when it comes to health industry? Yes, Melvin.
About naman po sa health industry, kung dati po na parang medyo mahirap pa yung pagda-diagnose, ngayon po pwede na po siyang through MRI, CT scans, X-rays, mga ganun po.
Yes, tama. Para kumbaga dati eh, ano nga yun, minsan may palaway-laway pa, ano. Eto pala, tapos yung malala na pala, ano, hindi natin naaalaman. So yun, nag-improve in terms of diagnosis nga, at saka yung paano siya mapiprevent at para early detection ng sa health. How about in education? Yes, Hans. Ito muna. Sige, Hans.
In education naman po is yung pag-aano po ng like before po is Manila paper lang, mga Artolinas, nagpipresent. Ngayon po is through PowerPoint na po, through yun, ganun na po yun ngayon.
Okay, tama. And other. Ano kanina eh, si Borge. Borge nga.
Opo, ma'am. Burge po. In education po, kung dati po, kailangan pa laging pumupunta pa po ng library para po mag-search ng ano. Ngayon po, one click away na lang po sa cellphone.
Yes. And yun nga minsan nagiging advantage at saka disadvantage din, ano. Paano siya nagiging disadvantage? Yes, Michael.
Too much relying po sa mga ano po natin, sa mga systems po na makukuhanan po natin ng information.
Correct. Minsan hindi na natin binabasa. Copy-paste na lang, ano. And maganda sana yung magiging advantage. Yes, Kiara muna. Sige.
Sa isa pa po sa education po ay like dati po ay wala po tayong ibang option sa mode po ng pagkaklase.
Mhm.
Hindi po katulad po ngayon na pwede na pong ganito na via Google Meet na po. Ganun po.
Okay, tama. Hans.
Anto, ma'am. Ngayon po, in disadvantage naman po eh,
Mm-mm.
minsan po ay sobrang pagkuha na po natin sa internet is nape-plagiarize na po is hindi naman po tama na for each student.
Correct. At sana may apply ninyo yan. Ano, hindi lang copy-paste. Kailangan nyo din kasi yon dahil minsan tinatamad tayong basahin na din yon. Lalo tayong walang naiintindihan dun sa sa information na nag-gather natin, which is dapat sana makatulong yun or makadagdag sa ating mga kaalaman. Okay. How about saan pa ba? Sa traveling. Yan. How about in traveling? Yes. Ibahin ko naman muna ha, wala nagang ibang sasagot dyan. Ito na lang mga ito ang aking estudyante. Yon, Dayan. Yes, Dayan.
Sa traveling naman po, bali, nakwento po ng tatay ko na sila po'y dati naglalakad lang.
Mhm.
Samantalang ngayon naman po ay may iba't iba ng transportation na magagamit.
Okay. Ako naranasan ko pa rin sumakay sa may yung hila ng kalabaw papuntang school. Naranasan ko pa. Sino pa? Yes, Hans.
Ano po, dati po before is laging walk-in para po makapag-asay tayo. Ngayon po is through internet or social media, pwede po mag-book kung kailan natin gusto. Yun.
Correct. Correct. That's correct. Yes, Kiara.
Sa sa pagtitingin po ng direction, dati po ay manual lang po talaga. Ngayon po ay pwede ka na po mag-check sa phone mo ng way po. Opo. Na mas madalas po ay accurate po ang direction po.
Ay, nice. Thank you. Yes, Melvin. Melvin?
Yung pinakaano po ay yung travel security po, na kung dati po ay kailangan mo pa ng mga certain process para maano lang yung iyong mabagahe. Ngayon po, may possibility na din po na magkaroon ng live tracking po sa actual mo po na bagahe. Pinapadeliver niyo po.
Yes, Kiara.
Same din po ng pero yun naman po ay live tracking naman po ng mismo pong tao po.
Mhm.
Ngayon po ay, dati po wala po talagang idea kung nasa na yung
Nasa na?
Opo, ngayon po ay may app na po na pwede pong ma-detect kung nasa na, like yung sa Life 360 po, gano'n.
Mm. Okay. Nice. Thank you sa participation ninyo. So, next. So, also it can affect yung or it can be useful and competitive advantage for businesses, di ba? O paano nga din, are? O kayo na din ulit. Biglang Wait lang. Sino yun? Yes, Hans.
Yun po, true business naman po. Ang technology naman po is sa atin para po hindi na po hassle for us. Yun, mag-sales stock through
Mhm.
personal. Ngayon po is pwede natin post online kung ano yung item na
Items, tama. Dati talaga nagpipinto-pinto, Yes, Aristotle.
Ma'am, dahil po sa technology ngayon, mas madali pong mag-advertise ng mga products at endorse po sa mas wider na audience.
Tama. Mga customer, range of customers. Yes, Melvin.
Yung pagiging mas advance ng ating stock market po na mas maganda natin dito po yung pag-track at pag-monitor ng mga products at saka po nung mga currency po natin.
Okay. Yes, Cyril.
Dahil po sa technology, katulad po nung pandemic po, marami pong businesses ang umusbong po. Tulad po ng mga live selling po.
Okay. Yes, Kiara.
Ma'am, yung way po ng pag-order po ng product po, dati po ay yung mismo store lang po, ngayon po pwede na pong online.
Tama. Okay, madami talagang. Yes, June, Ariel.
Ma'am, yung tulad po ng dati po na pa-traditional na pupunta ka sa store, tapos ngayon po nabigyan na po ng opportunities yung mga tao na kahit wala silang opportunity na magtayo ng store mismo sa mga tabing karsada is pwede nang maging online.
Tama. Tama yun. Parang kumbaga nag-improve din na hindi na natin kailangan mismo ng physical store or hindi na tayo kailangan magrenta ng ating store nga para parang nakatipid pa, di ba? Pwede na siya sa online. Doon na lang sa bahay, kumbaga ang mga stocks at Okay. Next is, so, what is electronics daw? So, electronics is the study of flow of charge through various materials and devices such as semiconductors, resistors, capacitors, and the likes. So all applications of electronics involve the transmission of power and possibly information. So yun nga, hindi lang yung electricity like yung sa mga wires natin, transmission, but also we can convey or we can exchange information wirelessly, diba? From our end-to-end, yung mga images, kayang-kaya na natin ipadala, or kahit bulk of data, kayang-kaya na natin ipadala over the internet. It is also another definition of electronics. It is a branch of engineering that deals with the design and practical applications of machinery and equipment for efficient communication. Examples are yung ating mobile devices, our computers, laptops, home security systems, and intelligence systems. And these are some examples of the present and emerging technologies. Wireless communication, satellite communication, nanotechnology, yung paliitan na talaga ng nakikreate na tawag dito, na electronic part. Then robotics, microwave communication, and iba pa. Biomedical, PLC, science instruments, optics, weather monitoring. These are the specialized fields ng electronics. And we have to, tayo ay pumunta muna magbibigay tayo ng kaunting glimpse ng history ng electronics. Sino-sino ba itong mga taong may kasalanan kung bakit tayo ay nag-aaral ngayon ng mga circuits at saka ng mga equations. So una ay si William Gilbert. Mostly, ito namang mga taong ito ay physicist and researchers, scientists, and mainly, ang kay William Gilbert ay magnetism and electricity. So mostly nga, lahat ng scientists dito ay with or connected ang kanilang mga sinesearch or nire-research on electricity and magnetism. So William Gilbert distinguished the difference between magnetism and static electricity. This is the first capacitor. Leyden jar. Medyo malaki pa talaga siya. So kung nakakita na naman kayo ng capacitor.
Yes po.
Okay. So syempre di kami maliliit na talaga siya ngayon. Ito, kung mapapansin nyo, yung first ever capacitor is bulky or malaki. Then si Benjamin Franklin is a writer and scientist who researched also about the electricity and weather and meteorology. Okay. He also defined the positive and negative charges and also marami pa siyang inventions. And yung mga dito, paunahan lang sila talaga sa pagpapapatent para mapapunta sa kanila yung sa kanila ma-acknowledge na sila talaga ang unang naggawa noon. So, nagiging dahilan din siya ng minsan conflict between dahil siyempre parang sabay sila nagre-research about that. Tapos pero nauna yung isa, sa feeling ng isa mas nauna dapat ako. Yung talagang na noon, kung sino ba talagang unang nakapagpa-patent or nakapagpa-lista na kanilang invention yun. He defined the positive and negative charges. Yun nga, nasabi ko na. Charles Coulomb, or yung Coulomb's law, he experimented the mechanical resistance and yun nga Coulomb's law of electrostatic charges. If meron kayong physics 1, wala.
Meron po.
Yan.
Pero physics lang po.
Wala kayong yung Coulomb's law. Na yung charge A, charge B, meron silang charges na papuntang left or right. Ano ang net charge nun at saan papuntang direction. Yun ang si Coulomb ang pinakaalaman niya. Pakailan pa ba natin kung saan pumunta yung mga charges? Talaga itong mga ito. Then si Luigi Galvani, he studied the effects of electricity on frogs. Of course, yun namang mga natin, tinetest muna talaga. Siyempre sa mga animals, frogs or sa mice. He revealed that animals had and were affected by electricity. Then si Alessandro Volta, he is very interested in electrical experiments. Of course, kumano ninyo yung tawag dito, yung unit na volt ay sa kanya ipinangalan. And he also invented the battery. Hans Christian Ørsted, he demonstrated that electricity is affected magnetism. He also initiated the study of electromagnetism and discovered aluminum, si Hans Christian Ørsted. André Ampère is a French mathematician and physicist and invented the solenoid. Of course, yung unit ng ating current ay named after André Ampère. You know, he studied the effects of electrical currents. While George Simon Ohm, he experimented on electrical circuits as well and made his own parts including the wire. He discovered the Ohm's law and yun nga ding unit ng resistance which is ohm was named after him. Yun nga, the Ohm's law is the relationship between the current, voltage, and resistance. Michael Faraday, also electricity and magnetism, and demonstrated the electromagnetic induction. James Prescott Joule, he discovered the law of conservation of energy. Also, alam ko natakal din to sa physics. And the unit of energy, yung joule, is named after him. Gustav Robert Kirchhoff, ito ang Kirchhoff's law, ay matatakal natin when we will, pag nasa ano na tayo, transistors and diode circuit applications. So, yung Kirchhoff's law, Kirchhoff's current and voltage law, magagamit natin yan sa pag-analyze ng mga electronic circuits. He also invented the spectroscope. Si Sir Charles Wheatstone is worked on telegraph, photography, and also electricity. He also developed the concertina or the accordion and founded the use of Wheatstone Bridge. Yung Wheatstone Bridge ay yung parang dito. Teka lang po, sirit na. Topology ng isang circuit, parang kumbaga ay series parallel, tapos meron pang ibang topology. That's yung Wheatstone Bridge, yung kanyang na-discover. James Clerk Maxwell wrote the treatise on electricity and magnetism. Tinan nyo, kung mapapansin talaga ninyo, more on electricity and magnetism. Dahil parang doon lang din naman talaga nag-start ang lahat. So the equation in it explained Faraday's work and predicted yung ibang work pa ng mga ibang scientists. While Heinrich Rudolf Hertz demonstrated the electromagnetic radiation predicted by Maxwell and first demonstrated the photoelectric effect. Wilhelm Röntgen discovered X-rays in 1895. So X-rays were used by doctors, and Max von Loo proved that they were electromagnetic in nature. Thomas Alva Edison, kung maano ninyo, ito yung sa bulb, ang ating incandescent bulb. Marami siyang patents. He has 1,093 patents, including the phonograph, the incandescent lamp. So yon, talagang madami. And also observed the Edison effect while inventing the electric lamp. So ito yung patent lamp ni Edison noong 1882. It is a carbon filament lamp. So yung ganyan. While Nikola Tesla is a Serbian-American inventor and engineer, he invented the AC generators and distribution systems and AC induction motors. He was hated by Edison daw, chika, because of course malamang yan ay usaping patent. Yun nga, siguro may nauna at kiniklaim niya na ako ang nauna. Pero ang nauna siguro si Tesla doon sa ginagawa ni Edison, kaya nagalit si Edison. Guglielmo Marconi patented the telegraphy in 1896, and in 1901, siya yung nakapag-transmit ng signal wirelessly across Atlantic Ocean. And he is a Nobel Prize winner in physics in 1909. John Ambrose Fleming is a student of Maxwell and worked for Edison and Marconi. He invented the Fleming valve, the first electronic rectifier or diode, in 1904. Ito yung kanyang invention or yung Fleming valve. Apo. Lee DeForest held more than 300 na patents. And in 1906, he invented the Odeon tube, the first triode vacuum tube. And in 1912, cascaded his tubes to increase amplification. Wait lang po. Any questions so far?
Wala pa naman po.
So let's continue. Okay, so this is the triode valve invented by Lee DeForest. So si Walter Scott Key had multiple doctorates, and he defined shot noise, the random electron noise in thermionic tubes, and in 1919 he invented the multiple grid vacuum tube. Si Edwin Howard Armstrong invented the regenerative feedback and electronic oscillators. Also, in 1917, he invented the super heterodyne radio and patented the FM radio naman in 1933. While Philo Taylor Farnsworth, at age 14, at 1922, he invented the electronic TV systems. Talagang wala silang magawa talaga noon ay walang mapagkaabalahan kundi mag-invent. And then in 1927, he patented his TV system. So of course, syempre pag na-prove natin yung invention natin na working and talagang yun na nga, ang next step natin is to patent it. Then, si William Bradford Shockley. Meron siyang kasama, tatlo sila. Si Shockley, si Brattain, at saka si Bardeen. Silang tatlo ang naging susi doon sa, kumbaga, sa laro ay naging turning point sa basketball. Naging turning point ng laro hanggang maging winner na Naging turning point siya sa history ng electronics when they invented yung transistor. So si Brattain worked with si Shockley worked with Brattain and Bardeen on a team who invented nga the transistor. And he shared the 1956 Nobel Prize. Yun nga, dahil pagkaka-invent nila ng transistor na yon. Walter Brattain worked on radar silicon detectors and of course, kasama din nga sa nag-invent ng junction transistor. Also, si John Bardeen. So, the electronic world, yung kung anong ina-enjoy natin ngayon was not just the effort of some years or decades, but it is also the results of hard works ng great minds, yung mga taong nasabi natin kanina. So that's why we are enjoying what we are enjoying today because sila yung nagpakahirap mag-invent nung mga iyon. So yon. So yung unang part, the early 1940s is the vacuum tube era. So yun nga, yung sa vacuum tube na si Lee DeForest, medyo malaki siya. Malaki talaga siyang electronic device. These are used for radios, television, telephone equipment, and computers. But they were expensive and bulky, fragile, and energy hungry. Kasi nga, hindi pa ganun ka-sophisticated yung technology, yung mga vacuum tubes malalaki, and hindi naman din ganun ka-powerful pa yung halimbawa, yung ay kaya na niya makapagpatakbo ng halimbawa 3 volts or na amplifier. Maraming vacuum tubes ang kailangan para makagawa ng isang electronic system. So, in return, yung isang electronic system, napakalaki din. Just like the first digital computer, which is yung ENIAC, isang buong room ang kinailangan para siya ay magawa. Pero kumbaga, ang ano lang niya, mga 3 MB lang na data ang kaya niyang store or i-process. Pero sobrang laki, di ba? Isang buong room yan nasa picture. So, the invention of the point contact transistor by Walter Brattain, John Bardeen, and William Shockley ng 1947 sa Bell Laboratories and won the Nobel Prize in Physics in 1956. Yung vacuum tube, medyo lumiit, pero mas powerful siya. Yung transistor, maliit compared sa vacuum tube, and also yung power capability niya at saka power consumption ay nag-improve. However, meron tayong reproducibility issue. Ang reproducibility issue kasi yung point contact transistor is made up of germanium, yung semiconductor element. While, ibig sabihin, kapag germanium, expensive pa din siya. And hindi siya abundant in nature. Kaya, yung pagre-reproduce noong nung point contact transistor na kanilang in-invent ay may issue pa din. Kaya, of course, CQI, Continuous Quality Improvement, na-invent ang bipolar junction transistor or yung BJT made up of silicon. Silicon, kumaano naman natin, made up of, from sand siya or silica. Mapapansin natin, syempre, or alam naman natin na siya ay abundant in nature, madaming sand available, and then cheaper compared to germanium. And nung na-invent nila ito, nakita nila na it is more stable and reliable. It was in 1950, also by William Shockley in Bell Laboratories. Okay, so that is the first commercial silicon transistor. Nasa $2.5 each approximately in 1954 yan. So before the invention of the integrated circuit, electronic equipment was composed of discrete components such as transistors, resistors, and capacitors. Okay, so sa isang electronic system naman, di bukod dun sa transistor natin, may resistors, may capacitors na pinagsasama-sama. Kung halimbawa din, magkikreate tayo ng isang system, pag pinagsama-sama din natin siya, magiging madami din siya. Madami siya, tapos complicated yung nagiging circuit. So these components, often simply called discretes, were manufactured separately and were wired or soldered together into isang circuit board. Ano ba natin aanhin yan? Wait lang. Google lang ako. Printed circuit board. Ito. Kita nyo naman ano? Hindi pala. Sorry. Sala. Percent. Yan. Kaya para makabuo ng isang electronic system, so madaming, may resistors, itong mga capacitors, na inihihinang daw, pinagsasama-sama sa isang circuit board. However, yung talagang gusto natin talagang mapaliit pa eh. Gusto mapaliit pa yan, and para yung space, imagine ninyo, yung cellphone. ang isang, halimbawa sa memory pa lang, kailangan ganyan ng kalaki. Paano nyo hahawakan yan? Hindi na siya magiging handheld. Kaya talagang inano noon na lagi sa buhay may improvement pa. So noon doon na-invent yung isang integrated circuit na kumbaga ito namang ang plan naman doon yung itong buong nasa circuit board na ito. Buong circuit board na ito ay mapapagsama-sama nila sa isang parang ganito lang. Yan, ito yung IC. Yan, yung ganyan din. Na nandito na sa loob yung resistors, capacitors. Yan, kaya nagkaroon tayo ng photolithographic process wherein yung process, buong process ng paggagawa ng isang integrated circuit ay nandoon na, pati yung mga resistors at capacitors ay doon na din. Nasa isang buong circuit na lang. Wait lang. Okay. So yan. So discretes took up a lot of room and were expensive and cumbersome to assemble. So engineers began in the mid-1950s to search for a simpler approach. Yun nga yung sinasabi ko kanina. Yung invention ng integrated circuit. So an IC consists of interconnected electronic components in a single chip of semiconductor material. So the first ever integrated circuit was made by Jack S. Kilby in 1958 and showed that it was possible to fabricate a simple integrated circuit inumpisahan na ulit nila sa germanium. Yan yung itsura. Kumbaga, siyempre, hindi pa rin naman maganda ang pagkakahinang-hinang noon. So, yan yung integrated circuit na yan. Yan, na ganyan lang talagang kaliit. Meron na siyang capacitor, meron na siyang resistor na nasa loob. Hindi na yung hihinangin mo pang meron tayong physical na capacitor at saka physical na resistor. While noong 1959 naman, si Robert Noyce demonstrated an IC made in silicon using silicon dioxide as the insulator and aluminum as the metallic interconnects. Ito yung planar process. Nakita ninyo? And then, meron din daw siyang mga capacitor na siya at saka resistor at saka transistor na nandyan sa loob na ganyan lang. Parang kumbaga yung metallic parts lang. Hindi na kailangan ng packaging. Nandyan na sa loob na yan. And the actual size is approximately 1.5 millimeters in diameter. So by connecting a large number of components, each performing simple operations, an IC that performs complex tasks can be built. So the degree of integration has increased in an exponential pace over the past 40 years. So yun nga yung sinasabi ni Moore's Law. Moore's Law na sabi, yung mga number of devices from yung kanina, halimbawa mga 3-4 lang, in years from yung ating dito, processor na 404 up to kung ilan na ngayon hindi naman Pentium. Ano nga yun? i5 or i7 na ngayon, ganun na kadami. Nag-grow na from, halimbawa, mga 2 to as years nagdo-double siya. Ayan, the number of devices on a chip doubles every 2 years for the same price. Kung halimbawa billions of transistors na ang nandoon sa loob ng isang chip ngayong year na ito compared dun sa 1970s na produce or 1950s na na-produce yung first ever IC na halimbawa 3-4 lang. Ngayon, yung nasa isang chip na maliit na yon, kaya nang nandoon ay billions of transistors, resistors, and capacitors, kaya na nilang samahin. So this is a silicon wafer wherein dito nilalagay yung or minamanufacture through yung planar process yung isang chip. Itong kada square na yan, meron siyang isang device. Halimbawa, siya ay isang yung processor na i7. So, napakadaming i7 ito. Na ipapackage pa, of course. Ima-manufacture pa din. And ipapackage into yung ang tawag doon? Para maging processor siya. So, yan. Bawa yung isang yan, merong through the technology, nandiyan dyan yung mga transistor, ground, capacitors, inductors, meron din kayang i-produce. Okay, wait lang po.
What we, for the sake of convenience, call a chip is officially called an IC, the abbreviation for integrated circuit. A chip is like a city with no people but bursting with activity. A chip is packed with industrial buildings, control centers in the form of components such as transistors and resistors, which together form one huge network. The chip's infrastructure carries vast amounts of fast traffic along roads and communication networks. The building blocks in chips are not only becoming ever smaller, but our designers are also making the chips cleverer all the time, so as to create new possibilities continuously. This makes the equipment controlled by these chips better, safer, easier to operate, more energy efficient, and friendlier to the environment. Let's stride in 7-league boots through the ingenious process by means of which products such as chips are produced at Philips Nijmegen. We'll explain aspects such as the most important steps in the production of ICs, and to make this easier to understand, we'll begin with a series of animations. A chip is an extremely small silicon plate, ranging from a couple to several dozen square millimeters in size. This tiny silicon plate is then filled up with a great number, sometimes millions, of microelements such as transistors, diodes or resistors, which together form an integrated circuit, the IC. We make a large number of chips all at once on a round silicon disk called a wafer or slice. First of all, we create a new layer of silicon on the slice, 1/100th of a millimeter thick. We then oxidize this silicon layer in an oven, so that an even thinner insulating layer is created on top of it. We then apply a coat of light-sensitive lacquer. We expose the lacquer through a kind of photographic negative, so that the lacquer dissolves in certain places. Then, in the places where there is no more lacquer, we shoot atoms with great accuracy through the oxidized layer into the silicon. The layer of lacquer is then no longer required, and is therefore removed from the slice. We then ensure that the atoms penetrate a little deeper into the silicon by a few thousandths of a millimeter. A new silicon layer is applied over the oxide layer. And once again, a layer of lacquer is applied, exposed, and developed. The silicon which is uncovered by this process is then etched away. Another series of treatments involving lacquering, exposure, bombardment with atoms which penetrate the silicon, new oxide layers, etc., is performed until the whole pattern is complete in all its layers. Some 300 to 400 process steps are required, along with 15 to 20 different masks with microscopically small patterns. The final step in the process is the connection of the various, almost invisible, tiny elements in the silicon. This is how we make an electronic circuit, an IC or chip. Naturally, we have a particularly good relationship with our suppliers, as they too play a part in determining the final quality of our products. Silicon is made from ordinary quartz sand, and rods of silicon are then created, or drawn, at extremely high temperatures. Thin slices are then sawn off these rods with great accuracy. The ICs will be produced on these slices of silicon, for which purpose the slices will undergo 300 to 400 processes. The first step in the production process is as follows. In this special oven, the slices are covered by a new thin layer of very pure silicon, into which the transistors and other components can be built. The slices with a new layer of silicon are placed in other boxes, where the silicon is allowed to oxidize. This insulating oxide layer can be removed at a later stage when necessary. These are known as the yellow rooms. Here, extremely intelligent, fully automated machines are used to apply the light-sensitive layer of lacquer to the oxide on the slices and to expose the slices. Yellow light is used in these rooms, as the lacquer is not sensitive to this. The patterns on the masks, a kind of photographic negative, are of course designed by our own development engineers. The templates themselves are made by other specialists. It goes without saying that we also cooperate very closely with these suppliers and equipment manufacturers. In these so-called implanters, specific atoms can be shot into the unprotected areas of the silicon to give them a positive or negative conductivity. This is done incredibly accurately. For example, 1 atom in 100,000 silicon atoms. One of the next steps in the process is etching, removing material locally from the slices with great accuracy. This department uses an automatically controlled process involving acids and caustics. Another technique used is dry etching with an etching gas. This picture gives an impression of the technology involved in this dry etching. All of the process steps we've seen, and many, many more, are repeated until the product has been fully assembled. This is what the smallest parts look like through a special electron microscope. Sometimes, the chip designers use a technique in which the chip is sawn through, so you can even look inside. The last step in the process involves making connections between the various elements in the silicon. These are so tiny that a minuscule vacuum-deposited layer of aluminium is required to make them. The innumerable processes, which take approximately 3 weeks to complete, are concluded by an initial visual inspection. Each chip is checked for a number of essential functions. After testing, chips which do not comply with the specifications are marked with an ink dot, so they'll no longer be used. Once they've been tested, the chips are ready for assembly. First of all, the slices are laid on a layer of adhesive film and then almost sawn through in 2 directions by a special, amazingly accurate sawing machine, so that the chips are almost separated. The slices are then carefully packaged and sent to the assembly centers in the Far East: Bangkok, Hong Kong, Manila, or Kaohsiung in Taiwan.
Okay, so yun yung process of manufacturing or fabricating an integrated circuit. So medyo hindi pa yung tapos. Yung nasa wafer na yon, papadala nga daw sa mga ang tawag dito, sa Asia, wherein yung labor cost ay mas mura compared sa US. So yung next na lang na ipapakita ko, next meeting na lang bukas, na time na tayo, 11. Okay po, may question muna. Sino may question? Any questions? Wala. Okay po, sige. Thank you.
Thank you po, ma'am.
Thank you po, ma'am.